Thank you very much for the introduction. It's great to be here. So today, the goal of in the next hour, what I want to give you guys is an overview of all the various different techniques that people have applied for reducing the energy consumption of processing deep neural nets, from the hardware up to the algorithm portion. And then the last part of today's talk, I really kind of want to emphasize what are the trade-offs that people are making and what are the limitations of the current techniques. So what can we do more to improve them? So just to start off, in terms of the research within my group, and actually probably one of the motivations why you guys are here, is that we like to primarily focus on the processing of video, because we believe video is the biggest of the big data. So I'm sure you guys already know that the internet traffic is dominated by video, and the amount of video that's being generated every day is more than what humanly we can actually watch. A lot of this video is being collected on battery-operated devices like cell phones. But due to the limitation of the energy that's available there, we often have to push it to the cloud. But this is not ideal for cases where you care about latency or privacy, or if you have limited communication bandwidth. So really, we want to try and be able to do a lot of the processing on the edge device. And that's really the focus of the overarching research within my group, is how do we do energy-efficient pixel processing? So that's the context of what we care about. Today, one of the most popular forms of processing that you actually want to do on this edge device would obviously be deep learning. And one of the driving reasons for that, of course, is because deep learning is offering significantly higher accuracy for a variety of computer vision tasks as compared to traditional handcrafted methods, right? So you all must have heard about, for example, starting in 2012 with AlexNet coming from the University of Toronto on this ImageNet competition. It showed substantial reduction in terms of the error. So in this plot, lower the better. And then since then, the error has dropped to, in 2015, it actually achieved an error rate that's actually below the error rate of, or actually beat human level accuracy. The challenge for all of this, of course, is that even though it's great to reduce the error rate, the challenge is that we actually require a lot more computation. So on these devices, we don't just care about accuracy, but we also care about energy, speed, and cost. And so this deep learning has become a real big challenge for this particular space, even though we know that for a wide variety of applications, it actually is giving us much higher accuracy.